All right, welcome guys. We're doing chapter 9, lesson 2. So the first lesson was just a prerequisite to this unit. So the unit is on radical functions, and lesson 1 was on inverse functions. So we needed that lesson to kind of introduce the unit on radical functions. So we're going to talk about square root and cube root functions and how to graph them. So our goal is to be able to graph square root functions and cube root functions according to the standard. So let's look at square root functions first. For square root functions, remember that the square root function is the inverse of the quadratic function. So we already graphed the quadratic function and we graphed the inverse of that in the previous lesson. So now we're going to be looking at transformations of that original function. So let's show you quickly how the square root function looked like. Remember that when we did this in lesson 1, and I'll kind of do this on the side, you guys don't have to write this, but in the first lesson we had, a quadratic function that looked like that. And then when we graphed the inverse, it kind of looked like this, right? And we had the plus square root version and the minus square root version. When we restricted, we got just this part of this guy. And then when we did the inverse, we got something that looked like this, right? So this right here is the square root function that we're looking at, the positive square root function. And that's how this should look like. So this is the parent function. We're going to graph that first. So in order to do this, well, we're going to just do an XY table. So let's look at square roots. Let's look at values that work out well. So x equals 0. The square root of 0 is 0. Let's look at another number that's nice. Square root of 1. What's the square root of 1? Just 1. Let's look at 4. What's the square root of 4? It's going to give me 2. So, and then let's do one more. Let's do 9. Square root of 9 is 3. All right. Now we can go ahead and graph that. So we got 0, 0. We got 1, 1. 4, 2. And 9, 3. Go ahead and draw the square root function, and there you go. It looks like this guy, which is the inverse of that half of that parabola. All right. So what's the domain of this guy? The domain are the x values. Remember, domain is x values. Range is a set of y values. So for the domain, we have x cannot be negative because we can't take the square root of a negative number without getting imaginary. So therefore, the smallest value is x equals 0. All right, so x has to be 0 to infinity, right? So x cannot be less than 0. So we're going to say that x is greater than or equal to 0, since it could be 0 and on and bigger. For the range, the smallest y value is 0 that it could be. You see that there's nothing below 0. And then, so that means that y has to be greater than or equal to 0. Another way of writing the x is greater than or equal to 0 is because I want you guys to see different ways of doing things. So another way of writing this is using the brackets. So if a bracket means that you're including the number, and you're going from 0 to infinity. All right, same thing here. You're including the 0. So bracket means you include the number. And then this is from 0 to infinity. All right, so that way you guys are exposed to different ways of writing stuff. So instead of just this, you can also write it using this notation. All right, so we're going to go ahead and graph the following square root function. So we're going to do 2 times square root of x. So let's do the xy table real quick. So we got 0, 1, 4, and 8. And 9, I'm sorry. It should be 9. So when we do this, square root of 0 is 0, and 0 times 2 is 0. Square root of 1 is 1. 1 times 2 is 2. Square root of 4 is 2. 2 times 2 is 4. Square root of 9 is 3. 3 times 2 is 6. I'm going to go ahead and plot this. So 0, 0, 1, 2, 4, 4, and 9, 6. Now we can go ahead and graph the square root function. All right, and there's our graph. So that the domain is the same thing as it was for before. X has to be greater than or equal to 0. So we're going to say x goes from 0 to infinity, or you can say x is greater than or equal to 0, same thing. The range is also from 0 to infinity, or you can say x is greater than or equal to 0, same thing. All right, so now let's go ahead and do this guy. We're going to use the same values for our x. All right, so now we got square root of 0 is 0. 0 times negative 1/2 is 0. All right, the square root of 1 is 1. 1 times negative 1/2 is negative 1/2. Let's do square root of 4 on here on the side. So we got negative 1/2 times square root of 4. Square root of 4 is 2. So that gives us negative 1/2 times 2. 2 is the same thing as 2 over 1. So you multiply straight across. So we got negative 2 over 2, which is negative 1. So we got negative 1. All right, so now 9. So square root of 9 is 3. So we have negative 1/2 times 3. 3 times negative 1/2 is negative 3/2. All right, so that is our table. So we got 0, 0, 1 and negative 1/2, 4 and negative 1, and 9 and negative 3/2. All right, so then let's do our domain. Our domain is all x values that are bigger than 0, so that stays the same. This time our range is different because now we have negative values. So the biggest value that y can be on top is 0, and then it just gets smaller and more negative from there. So that means that y has to be less than or equal to 0, which is the same thing as going from... So if y is less than 0, that means that y starts out at negative infinity. All right, so since y starts out really small, so you can write this as negative infinity. So negative numbers all the way to 0. All right, so that's another way of writing it. So then what happens? What's the difference between this graph and the parent function? Well, notice that this is the parent function, and for number 2, if you have a number out in front, which is the 2 there, that if that number is bigger than 1, like 2 for example, then that actually stretches the function and makes it go up, right? So it stretches it. It's a vertical stretch. And then for this third graph, it actually reflects the negative in front of the square root actually reflects the graph about the x-axis. See how it reflects it and makes it go downward. And then the 1/2, since that 1/2 is smaller than 1, that actually makes it skinnier or smaller. So it actually compresses the graph and makes it smaller. So what do the numbers do in front of the graph? Well, if the number is greater than 1, then it is a vertical stretch, which makes the graph so it makes the graph look wider. So basically it makes it bigger, or we'll just say wider. So if the number is less than 1, then it is a vertical compression or shrink. Compression and shrink are the same thing. So it's a vertical shrink or vertical compression. So it shrinks the graph or compresses it, which makes the graph look narrower or smaller. So narrower or smaller. If the number is negative, then this is a reflection about the x-axis. All right, so if the number in front of the square root is negative, then that's what happens to the function. Now let's look at a different scenario. So we're going to do square root of x plus 3. So same deal here. This time, instead of doing x is equal to 0 and here, let me change these up. So instead of doing x is equal to 0, I'm going to choose a different number because I want the square root to be a nice number. So what I'm going to do is I'm going to change the x value so that makes this a smaller number. So what makes x plus 3 equal to 0? The only way to make that 0 is with negative 3, because negative 3 plus 3 is 0. And then what's the square root of 0? Just going to be 0. Now let's choose another nice number. The other nice number that we need is square root of 1, because square root of 1 is 1. So that means that this has to be negative 2, because negative 2 plus 3 is actually going to give me 1. So square root of 1 is 1. What's another nice number? Well, another nice number is 4, right? Square root of 4 is 2. But 1 plus 3 is 4, so that means that x has to be 1. So then 1 plus 3 is 4, square root of 4 is 2. See how I'm doing that? I'm trying to choose nice numbers so that I can graph it. And then square root of 9 is my next good number, so square root of 9 is 3. So I need x to be 6, because 6 plus 3 is 9. So I'll make this 6. So square root of 9 is going to give me 3. All right, now we can graph it so that we can get a nice looking graph. Negative 2 and 1, 1, 2, and 6, 3. All right, so then that means the domain is different. Now the domain is starting at negative 3 and going from negative 3 onwards. So that means x is greater than or equal to negative 3, or you can say a domain is from negative 3, including negative 3, to infinity. The range is when y is greater than or equal to 0. So that means it's going from, oops, need to erase that. It's going from 0, because you got to include 0, so you need the bracket, the square bracket, to infinity. All right, now let's do this one. We're going to do the same thing what we did here. We need to choose some nice numbers under the square root. So let's choose some nice numbers. So let's do 0. Square root of 0 is 0. So we got to do 1 minus 1 is 0, so x has to be 1. All right, so square root of 0 is 0. 0 plus 3 is 3. Now let's choose another nice number. Let's make the square root of 1, because square root of 1 is 1. So x could be 2. 2 minus 1 is 1. Square root of 1 is 1. 1 plus 3 is 4. Let me make this a little nicer. There you go, so 2 and 4. All right, so then another nice number would be square root of 4. So that means that this has to be 5. 5 minus 1 is 4. So let's make x equal to 5. 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. Now let's do let's do this 9. Square root of 9 is 3. So x has to be 10. 10 minus 1. So 10 minus 1 is 9. Square root of 9 is 3. 3 plus 3 is 6. All right, so now we can go ahead and graph this. So we have 1, 3, 2, 4, 5, 5, and 10, 6. All right, so domain, it looks like the the minimum x value is 1, so it goes from 1 and on for the x value. So x has to be bigger than 1 or equal to 1. So x has to be greater than or equal to 1, or you can use the 1 to infinity. The smallest y value is y equals to 3. So that's right here. And then it gets bigger from there, right? So that means the smallest y value, so y has to be greater than or equal to 3. Or you can say it goes from 3 to infinity. All right, so then what did the numbers do to the graph? So in this case, the plus 3 shifted it left. So the original actually started at 0 and it shifts left. And then for number 5, well, the minus 1 seems to have shifted it to the right by 1. And then the plus 3 seems to have shifted it up 3. So that's what it does to the graph. So the number under the radical sign. So the plus 3, if the number is negative underneath the radical sign, which is for number 5, then it shifts it right. If the number is positive, which is number 4, then it shifts it left. All right. So the number outside of the radical sign. So if the number is negative, so if there's a number outside of the radical sign, like in number 5, then and if it's negative, it shifts it down. So so this would be shifted down if this were minus 3. And if the number is positive, like this one, plus positive 3, then it shifts it up. So in this case, it shifted it up 3. So the number inside the radical sign or under the radical sign shifts it left or right, and the number outside shifts it up or down. All right, so now we're going to combine the transformations. So we're looking at this function right here. So describe and graph the transformations on the parent function. Oh, also, I should also note to you guys, and I'll write it over here. If you have a negative inside the radical, so this is not in the notes, but just in case you get this question, if you have a negative inside the radical, like negative x, the negative inside, so the negative inside in front of x means that you're going to reflect the graph about the y-axis. All right, so I forgot to put that in the notes. So if you had a negative square root of x, then instead of having this guy, you're going to have something that looks like that. Okay, so this would be the graph if it was negative on the inside. All right. So just something to keep in mind. All right, so for number 6, we're going to graph this guy. So we know that there's a negative in front of the radical, which means that we're going to reflect it about the x-axis. There's a plus 2 here, which means that it's going to shift left. I forgot to write the word shift here. So shift left 2 units. And then here there's a plus 5 on the outside, which means I'm going to shift up 5 units. All right, so I'm going to quickly draw this graph. So So I'm going to show you both graphs. I'm going to show you the original and I'm going to show you the new one. All right. So the original is 1, 1, 2, 4. I'm sorry, 1, 1, 4, 2, 4, 2, and 9, 3. So this is the original. I'm going to do the original in black, and I'm going to do the answer in blue. Okay, so this is the original. So the black is the parent function. Okay, and then the blue is the answer. Okay, so let me do that in, actually, here, let me see if I can, there you go. All right, so that means we're gonna shift it left 2 units. Actually, let's do the reflection. So it's gonna reflect about the x-axis, right? So it's going to, instead of, it's gonna reflect about here. So it's gonna look something like that. So it's gonna reflect here, and then it's gonna shift left 2 units. So this is gonna shift left 2 units. So 1, 2. Let's do left 2 units and up 5 units, so that way we can take care of it at once. So left 2 and up 5. So 1, 2, and then 1, 2, 3, 4, 5. So that is right there. Now let's do the same thing for the other one. So 1, 2, and then 1, 2, 3, 4, 5. So it's over here. Let's do the other one. 1, 2, 1, 2, 3, 4, 5. There you go. So now we can go ahead and graph the function. All right, so there you go. There's our graph. So again, the blue is the answer. All right, so you could do it. So this is how you do it with the transformations, like, you know, with the parent function, and then you shift it or whatever. You can also use the table. All right, so there's not one way of doing it. You can do it either way. So you can use the transformations, or you can do a XY table and then graph it. All right, but you do have to understand, you know, transformations and how to do them, and like how to describe the transformation. Now let's go ahead and look at cubic functions. So cubic functions are obviously going to be a different looking graph than a square root function. For the cubic function, you need to know the certain cubes, all right? So you need to know that, you know, like 0 cubed is 0, 1 cubed is 1, 2 cubed is 8, and 3 cubed is 27. Okay, so those are some of the main ones that you need to know. That way, so that means the cube root of 27 is 3, the cube root of 8 is 2. All right, so keep that in mind because you're going to need to know those facts. All right, so the cube root of 8 equals 2, the cube root of 27 is 3. And cube root of 1 is 1. Cube root of 0 is 0. Okay, so those are some of the main cubes that you're going to need to know. So let's go ahead and do a quick XY table. Let's do it down here. So we're going to choose some nice numbers. So 0, 1, 2, and 3. Oops, sorry, wrong numbers on these last two. We need them to be perfect cubes, so we're going to choose 8. And then the last one's going to be 27. Obviously, we can't graph 27, so I'll just leave it at 8. All right, so the cube root, and let's choose some negative numbers here too. Remember that, let's write some negative numbers here too. So negative 2 cubed is negative 8, and negative 3 cubed is negative 27. All right, so that means the cube root of negative 8 is negative 2. The cube root of negative 27 is negative 3. So you can have some negative numbers in here too. So I'm going to also include some negative numbers. So let's do negative 8, negative 1. All right, so the cube root of 0 is 0. The cube root of 1 is 1. The cube root of 8 is 2. The cube root of negative 8 is negative 2. That's what we wrote here. Cube root of negative 1 is negative 1. All right, so let's plot it. So we got 0, 0. We have 1, 1, 8, 2, negative 8, or negative 1, negative 1, and negative 8, negative 2. So there you go. Now we can go ahead and proceed the graph. All right, and that's how the cube root function looks like. So notice that the cube root function has the plus version and the negative version automatically, and it's all one graph. All right, and it's a function since it passes the vertical line test. So the cube root has plus and negative version, whereas the square root only has the positive version if you're just doing the one graph. All right, so in this case, the domain is all x values. So we can either say all x. So there's a couple ways to write it. You can say negative infinity to infinity, or you can say all real numbers. All right, same thing, all real numbers, or negative infinity to infinity. To say all real numbers, there's also a symbol, and that symbol stands for all real numbers. All right, so there's a couple of different ways to say it. You can say all real numbers. You can use this R symbol. It's just an R with an extra little number, a little extra little dash there, and then or you can use the interval notation. All right, so then the range looks like all the y values are included here because this gets smaller and smaller, this gets bigger and bigger. So we can do negative infinity to infinity, or you can say all real numbers. All right, so now let's go ahead and do some different versions of the cube root function. So let's quickly do an xy table. We're going to choose positive values and negative values. So let's choose negative 8, negative 1, 0, 1, and 8. So the cube root of negative 8 is negative 8, but then there's a negative symbol there, so it makes it positive 8. The cube root of negative 1 is negative 1, but then there's a negative symbol there, so it becomes 1. I forgot to add 4 to it, so 8 plus 4 is 12. So I forgot to add that, my bad guys. So 8 plus 4 is 12. All right, and then let's do cube root of negative 1. So cube root of negative 1 is negative 1, negative 1, and then there's a negative in front of it, so it makes it positive 1. 1 plus 4 is 5. Cube root of 0 is 0. 0 plus 4 is 4. Cube root of 1 is 1, and then we have a negative in front of it, so it's negative 1. Negative 1 plus 4 is 3. We have cube root of 8, which is 2, I'm sorry. And then, but there's a negative in front of it, so negative 2 plus 4 is 2. All right, let me make sure I got everything right. So let me make sure that this is right here. So the negative 8, the cube root of negative 8 is negative 2. I think I said this was negative 3, guys. That was my bad. So the cube root of negative 8 is negative 2. And then you have 2 negatives, which makes it a 2. 2 plus 4 is 6. Okay, so that should be 6. My bad, guys. So we'll change that to a 6. So let's change that to a 6. All right. There you go. Now it should look pretty good now. Now let's go ahead and graph it. So we have -8 and +6. -8 is around here. Oops. -1 and 5. 0 and 4. 1 and 3. 8 and 2. All right, so now we can go ahead and graph it. All right, so there you go. There's our cube root function. Now let's go ahead and do this one. All right, so we're going to choose some nice numbers here. Remember, so we need this to be a 0 or a 1, all right, or a -1. So we need this to be a nice number, okay? So follow along with the logic here. So we have, let's make this let's make it into a -8. The only way to make that into a -8 is if x was -11. All right, so -11. -11 plus 3 is -8. Cube root of -8 is -2. All right, so let me write that on the side where we have some room so you guys can see it. Cube root of -11 plus 3, and then 1/2. So that'll give me cube root of let's put the 1/2 out there, of -8. So the cube root of -8 is -2. So 1/2 times -2 is going to be -1, because this cancels and gives me -1. All right, so this will be -1. Now let's make this inside into -1, so that means x has to be -4. All right, so because -4 plus 3 is -1. Cube root of -1 is -1. -1 times 1/2 is -1/2. Now let's make this into 0. The only way to make that 0 is if x is -3. -3 plus 3 is 0. 0. Cube root of 0 is 0. 0 times 1/2 is 0. So now let's make this into 1. The only way to make that 1 is if x was -2. -2 plus 3 is 1. Cube root of 1 is 1. 1 times 1/2 is 1/2. All right, now let's make it into an 8. So 5 plus 3 is 8. So that means this has to be 5. So 5 plus 3 is 8. Cube root of 8 is 2. 2 times 1/2 is 1. Okay, I'll show that on the side here so you guys can see it. Cube root of 5 plus 3. So that's 1/2 times cube root of 8. Cube root of 8 is 2. Remember, 1/2 times 2. 2 is the same thing as 2 over 1. You can think of it as doing 2 times 1, 2 times 1, which is 2 over 2, which is 1. Okay, so there's different ways to looking at it. I just want to make sure that you guys are understanding how I get those numbers. So you got -11 and -1, so you're all the way over here. -4, 1, 2, 3, 4, and then -1/2. -3, 0. -2, 1/2. And then 5, 1. All right, so there's our graph. So it just goes continuous. So then what happens? Okay, so let's do the domain real quick. So for the domain is all real numbers. All right, so that means it's -infinity to infinity, all real numbers. Or you can use a symbol for all real numbers. The range is also all real numbers. That doesn't change. Or you can use a symbol there. Is this an even, odd, or odd function, or neither? Remember that even is, so if we're asking even, that means even is where it reflects So it's a reflection about the x-axis, or about the y-axis. Odd is reflection about the origin. And in neither, it's just going to be neither. So in this case, if you look at this function, the original parent function, this is a reflection about the origin. The origin is the middle, so it's a reflection about the middle. So this is an odd function. So the cube root function is an odd function. In this case, so the parent function is an odd function because it's a reflection about the origin. In this case, since this is shifted up, it's not a reflection about the origin, so this is neither. Same thing here. It's not a reflection at all. It doesn't even look like a reflection, so this is going to be neither. The domain is all real numbers. The range is also all real numbers. Okay, you can use that or the negative infinity to infinity. Same thing. All right. So what about the transformation? So just like the square root function, right? If there's a negative in front of the radical, that means that it's a reflection about the x-axis. So this guy got reflected about the x-axis, because remember, normally it looks like that, but it ended up getting reflected. I'm just going to draw this, but I'm going to erase it. So it ended up getting reflected like this. All right, so that's how that looks like. You see that shape? And then it got shifted. So let me go ahead and erase that again. I just wanted to show you guys that. So it got reflected about the x-axis, and it got shifted up by 4. So that's what happened to that graph. So this is a reflection. So reflection about x-axis and shift up. How much was it? Up 4. All right. Now let's look at the other one. So the other one, you had the 1/2 there. So what the 1/2 does is it shrinks it vertically. So it's a vertical shrink because that number is less than 1. So it makes the graph look smaller. You see how skinnier it looks? So it makes it look skinnier or narrower. And then the +3 shifts it left 3. So this is a vertical shrink or compression, same thing. Vertical shrink by a factor of 1/2, and it shifts it. So shift left 3. So it shifts it left by 3 units. All right. So we're going to show you how to do this graph using the transformation, okay? So instead of using the table, right, which we used the table for the previous two, let's practice this without the table. All right, so I'm going to draw the original in black, and I'm going to draw the answer in blue, all right? So the answer is going to be in blue. All right, so the original function looks like this: 0, 0, 1, 1, 8, 2, negative 1, negative 1, negative 8, negative 2. So that's how the original looks like. So that's the parent function. So now we're going to do what? We're going to reflect that about negative 2. So reflect. So let me write out the transformation. So reflect about x-axis. We're going to shift to the right by 1. And shift, this shifts it up 1. Shift up 1. All right, and then there's the 2 there. The 2 does a vertical stretch. So vertical stretch by factor of 2. All right. So let's do the vertical stretch first, because I feel like that would be easier to do in this example first. So we're going to stretch it. So that means that instead of it being 1, it's going to stretch to 2. So basically, we're going to multiply the number here by the value, the y value, by 2. All right. So instead of it being 1 times 2 would be 2. All right. So let me do that in blue, but I'm going to do it lightly because that's not the final answer. All right. So it's going to stretch to 2. So don't graph this yet. It's just there to help you so far. And instead of it being 2, it'll stretch to 4. It'll double, stretch by a factor of 2, because 2 times 2 is 4. And then instead of it being -1 times 2 would be -2. And then instead of it being -2 times -2 would be -4. So it'll stretch it. So you see how it's kind of stretched. And then, so we did the stretch part. So that's done. Now let's do a reflection. So we're going to reflect it about the x-axis. So instead of it being 2, it's going to be down here at -2. So now I'm going to erase this guy. Instead of this being 4, it'll be at -4. Instead of this being at -2, it'll now be at, oops, let me erase that. Instead of it being 2, instead of it being a -2, it'll now be at 2. Instead of this being a -4, it'll now be at 4. All right, so let me now erase this, so we won't confuse ourselves. So now it looks like that. And then now we're going to shift each of those points to the right by 1 and shift up 1. So I'm going to shift it right 1 and up 1. So to the right 1 and then up 1 and up 1, sorry. So just right 1, up 1. So that's over here. So I'm going to go ahead and erase that now. Right 1 and up 1. So that's over here. So I'm going to erase that now. Right 1, up 1. Okay, so now I'm going to erase that now. To the right 1 and up 1. So I'm going to erase that now. All right, now we can go ahead and draw the final graph. I'm going to do this the best I can. Let's try to do from here to here. Okay, let me do those points bigger. All right, there you go. All right, and there's our graph. So it's a reflection. It's shifted up a little bit. It's shifted to the right a little bit. And it's stretched up a little bit. All right, and that's our final graph. Again, you can do this using the table, and you'll end up getting the same kind of graph. All right, so if you were to do the table, let me just quickly show you how to do that. So if you were to do the table, right? Let's do that. Let's do it over here. Let's just do a couple of values here so you guys can see it. So if you chose x as 1, for instance, all right, 1 minus 1 is 0. Cube root of 0 is 0. 0 times 2 is 0. 0 plus 1 is 1. So that gives me 0, 1. Okay. And then so you get 1, 1. So that's, over here, 1, 1. All right, so 1, 1. So you're not going to get the exact same points that we got here, you and I, when we did this, the blue, but you'll get the points on the curve. So 1, 1 is there. Now let's choose another number. Let's do x is 2. So 2 minus 1 is 1. Cube root of 1 is 1. 1 times -2 is -2. -2 plus 1 is -1. So you get 2 and then -1, which is over here. All right, so you'll end up getting the exact, you'll end up getting either the same points or, different points, but you'll still end up getting the same graph. All right, so that's just an example. So you can always use a table. All right, so that is it for the lesson, guys. So you need to know how to graph cube root and square root and know about the transformations. All right, good luck, guys, and I'll see you later.